Woohoo! We are live. This is Math 60 5.7. This is a section on factoring certain polynomials that come in two terms. These are binomials that will factor using something called a difference of two squares. So we're going to start off with this wonderful formula, a plus b, the quantity a plus b times the quantity a minus b, ends up giving us this polynomial if you FOIL it, and you have an a squared minus ab and then plus ba. And those two, with my magical yellow highlighter, those two terms cancel. They get smaller. So I can do my and we end up with just a squared minus b squared. So here's the formula. If we have a squared minus b squared, that factors as an a plus b and an a minus b, and we call this the difference of two squares. Now, you may notice that this is also the product of a sum and a difference. It's the same formula, just depends on which side we're interested in. So if I ask you to factor, your goal will be to write the expression out as a difference of two squares. So for example, x squared is x squared. 9 is 3 squared. Once you break it down into something squared minus something squared, in this case it's a squared minus b squared, then we write it out as a plus b times the quantity a minus b. Now you can choose which one goes first. If you want to lead with the minus, a minus b, then a plus b, that is fine. X plus 3, x minus 3. Bam, it's that easy, we're done. Well, it's not going to stay that easy forever. So let's try the next one. Slightly more complicated, but still, these are some of my favorites. Again, we want to write this as the difference of two squared things. Now, suddenly everything has gotten a lot more complicated. This escalated quickly, did it not? So I've got the number 25. How do I write that as a square? What's the square of 5? So I've got 5. Now think about, I've got y to the 6th. I want that to be the square. I got to put something inside, so it's going to be y to some power inside. When I square it, I want to get to 6. Remember, if there's a power on the inside and a power on the outside, we multiply. So what times 2 gives you 6? You got it, 3. So this is 5y cubed. The other way to look at it is you just take half. So if it's y to the 6th, you take y cubed here. Okay, second term, 49. And I'm thinking, what squared gives me 49? You're right, it's 7. And what squared gives me x squared? Well, x. This is the hard part. Once we've written it out that way, right, that's our a squared minus b squared. We just have to remember that we've got a plus b times the quantity a minus b. And just so we have more room, I'm going to write it down here. I think I've got 5y cubed plus 7x, right? Those are our a and b right there. And then 5y cubed minus 7x. Woohoo! We almost ran out of room, but we didn't. That's how great this section is. Okay, next up. Oh no. Oh no. 5 is not a perfect square. The world is spinning out of control. Whatever will we do? Well, remember that what we're going to do is we're always going to pay attention to looking for common factors before we do anything else. And this polynomial, it has a common factor of 5. So let's factor out the 5. 5 with a 5 taken out leaves the 1, just a 1 to hold its space. And then minus, and then if we factor out the 5, then what we've got is p squared q to the 6th. Who in the world came up with this problem? This is a terrible, terrible problem. But okay, heads will roll, but let's keep trying. So I've got 5, and you know me, how I love to write things as brackets. So I'm going to write it as brackets to give myself some more room. And then I'm going to go ahead and say, okay, this thing inside, I think it's a difference of two squares. I've got the minus in the middle. One is a perfect square. So if I can come up with a second perfect square, which gives us p squared q to the sixth, right there, then I can use this formula. So remember again, I'm going to say what squared gives me p squared? Well, it's going to be p. What squared gives me q to the sixth? Remember, you go for half. That would be q cubed. This is why I think the person who wrote this problem was a terrible person, making us say q cubed. That's just wrong. Okay, so how do we expand this? Let me try doing this without writing the formula out. A difference of squares, a squared minus b squared. First, I take the two things added together, and then I take the two things subtracted. And that's all it is. Woohoo. Okay, one more problem. Chun-dun! Now, this is a tricksy one. There's an x squared. There's a 9. This is x the quantity squared plus 3 the quantity squared. So it should factor, except, oh no, a plus. This is specifically a difference of squares. A squared plus b squared is prime. Now, this is a little lie. It won't stay prime. If you go on to another semester of algebra at City College, you will find out that, in fact, you can factor this, but it's going to take some work that we're not ready for yet. So for right now, we're going to say we can't factor it, and then you'll factor it later. The other thing to think about is you always should check, make sure there are no common factors. If there are common factors, factor those, and then what's left is prime. Woohoo! Awesome. Okay, next up, everyone's favorite, sum and difference of cubes. Such a lie. No one likes sum and difference.